All right, guys, are there any questions on any of the assignments thus far? Any question over anything we've done so far?
It's kind of simple.
What we're doing today is factoring. We're going over factoring. Now, we've done factoring before. Now, all the factoring we've done up to this point has mainly been dealing with quadratics. Now, a lot of the factoring that we can do with higher degree polynomials still works. Now, for the most part, when we look at these first few here, we're actually doing the same properties we would do with quadratics. Same type of factoring we would use up to this point. So if we look at the first one here, we have x cubed minus 4x squared minus 5x. Now again, when we factor any of these here, especially the first ones we'll look at, is there a greatest common factor between these three terms? Well, there's not a number, but they do all have an x in common, yes? So we can factor out a variable. So I can factor an x. I can pull an x out of all three terms. Now if I pull an x out of x to the third, I'm left with x squared minus an x out of x squared is going to leave us with just 1x. And if we factor an x out of 5x, we're just left with 5. So just by pulling that x out, what we have left inside the parentheses is x squared minus 4x minus 5. We can actually factor that. And we did that in the last chapter. We already pulled out the greatest common factor, so we can set it up as two sets of parentheses with three spaces. And we look at the sign of the third term. Well, the sign of the third term is negative, so our signs are opposite. One's positive, one's negative. Now we look at the factors of the first term, x squared, which would be x and x. Now we also need to look at the factors of 5, which are, well, 1 and 5. Which one would we want to be positive and which one's negative? Positive 1, negative 5, and we can check x times negative 5 would be negative 5x. 1 times x is going to be plus x, which will give us a negative 4x, which is what we wanted. So here's the factored form. So for some of these here, if we just pull out a greatest common factor, we can actually factor it the way that we did before. Questions on this first one here? All right. We can look at the next one, 3y to the 5th minus 48y squared, or y cubed. Is there a greatest common factor between these two terms? Could be. Because they both have 3 y's in common, so we can pull 3 out. Anything else we can factor out? Yes, 48 does divide by 3, so there is a greatest common factor of 3y cubed. And if we factor this out, well, 3 factored out of 3 is just going to be 1. If we take 3 y's out of 3y to the 5th, we're left with y squared minus 48 divided by 3 is going to be 16. And if we take 3 y's out of y to the 3rd, we're left with 1. We don't have any left. Questions on this here? Can we factor y squared minus 16? What is it? It actually has a special name. It is a difference of perfect squares, because y squared, y times y. 16 is 4 times 4. And this is one of the ones that I think that y'all like better than the rest, because this is talking back to a squared minus b squared is our a plus b times a minus b. Well, in this case, a is y and b is 4. And we have opposite signs. Any questions on this so far? And for the most part, these first few that we're going to do is really just having some greatest common factor that includes a variable added on to what we've done already. Any questions on A or B? Yes, this should be, yeah, it should be y cubed. I just dropped the number from 3 to 2. Was not on purpose. Any other questions on these here? Let's look at these next two here. We have 5z to the fourth plus 30z cubed plus 45z squared. Is there a greatest common factor between these three here? Well, yes. We have what? 5z squared, and we can factor these out of each term. If we factor 5z squared out of 5z to the fourth, we're just left with z squared. 5z factored out of 30z squared is going to be plus 6z. And 5z squared factored out of 45 is going to be plus 9. So now we can set up our two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and they match the sign of the middle term, which is also positive. So we'll have plus and plus. Factors of z squared is going to be z and z. Well, factors of 9, we have 1 and 9 or 3 and 3. Well, the 1 we'll want is 3 and 3. And if we did check it, this is what we would get. And I mean, we could have rewrote this as 5z squared times z plus 3 squared, because they are the same set of parentheses. It would be the exact same thing. Any questions on any of this here? I'm going to skip that next one and look at b, 5y to the 6 minus 125y to the 4th. Is there a greatest common factor between these two terms? Five y to the 4th. Luckily, factoring out variables is not too bad, because if we look at them, we see which variable has the smallest power between all of them. So here 4, so we can pull 4 out of all of the terms. So 5 factored out of 5 is 1. If we take 4 away from 6, we have not 6, but we have 2. Back up. Minus 125 divided by 5 is 4. And if I take 4 out of 4, we're left with 1. This factors out completely, so we're just left with y squared minus 4. Now, y squared minus 4 is kind of nice because that is also a difference of perfect squares. Huh? 125 divided by 5? Yeah. No, it should be, let's see here. No, you're right. I was getting ahead of myself. Because 5 goes into, this should be 2 times, which is 25. Yeah, I was looking for a perfect square, and I don't know why my brain just said 4, but it did. Thank you. I was probably thinking of the y to the 4th. Any questions on this here? Well, luckily it still stays the same that this is a difference of perfect squares. So what would this factor do? It's y minus 25. Well, we would have the plus and minus, yes? Y and y, and then 5 and 5. That's it. Any questions on any of these here? What do we think of these so far? Yes. Thank you. This must be a Monday. Yep. So probably most of you already wrote 4. Any other questions on any of this here? Okay. Do we feel pretty comfortable with most of these here? We feel pretty comfortable with these here? Yeah. As long as I can stop tripping over my own feet, we should be pretty good. Now, the first kind of new thing we want to look at today is this here. The sum and difference of 2 cubes. So when we have 2 terms that are a perfect cube, that are multiplied by themselves 3 times, they will factor into this form here. So if we have a cubed plus b cubed, we get a linear term, a plus b, because the power is 1. So a plus b times a squared minus ab plus b squared. Or if we have a difference, a cubed minus b cubed, we get a minus b times a squared plus ab plus b squared. Now they didn't write this in, and you don't have to write this in, but inside our quadratic, a squared is really also being multiplied by b to the 0. Well, we don't write that in, because b to the 0 power, anything to the 0 power is what? 1. So we're really saying 1 times a squared. Now, if we look at this here, well, we have b to the 0, b to the first, and b squared. So the powers of b are going from 0 to 2. They're increasing by 1. And interestingly enough, actually with b squared, we also have a to the 0. Well, a to the 0 is just 1. So the powers of a are decreasing. So we're going a squared, a to the 0. They kind of do this up and down kind of pattern. So the first term's being squared to the first power, and then it's gone. B, we don't have a b term, b to the first, and then b squared. So they kind of have this up and down path. Do we kind of see that there? Okay. And it's going to work out that way every single time. We have a squared, a to the first, a to the 0, or no a term. We don't have a b term, b to the first, and then b squared. Now, if we look at the signs, they actually do have an interesting pattern, because the sign will match. Because in the first set of parentheses, the sign is the same. Opposite always end on a positive note. So here we have plus, this is what we started with. So we have the same, opposite, always end on a positive note. For the difference, because it's a difference, it's minus. Well, we have the same, opposite, always end on a positive note. I mean, the patterns for this are actually pretty nice. It's pretty easy to get once you see the patterns and how they work out. Questions on this so far? Pretty good so far. When we look at these quadratic, or not quadratics, these sum and difference of perfect cubes, the signs are going to follow. That is going to be the same, opposite, always ended on a positive note. This is how it's going to follow every single time. Now, if we look at this first example of the sum or difference of perfect cubes, we have this here. X cubed minus 125. X cubed minus 125. Now, whenever we have this here, we're going to need to find out what a and b are. Because in both cases, the general form is with a and b. So we'd have a plus b times a squared plus 2, or plus ab plus b squared. Or in either case. Now, when we look at this here, the first thing we can do is start off by drawing our parentheses. We'll have 2 sets of parentheses. One's going to have 3, and the other's going to have 5 spaces. So we have 3 spaces and then 5 spaces. Now, the first thing we're going to put in is the signs. So the signs are going to be the same, opposite, always end on a positive note. So for this one here, we have subtraction. So it's going to be the same would be minus, Opposite would be plus. Always ended on a positive note. So in any case, either one, sum or difference, will always have 2 addition and 1 subtraction. There's always going to be 2 and 1. One of the pluses will always be at the end. The other plus is either going to be in the first set of parentheses or the second. Questions on this so far? Now the rest of what we plug in is going to be dealing with A and B. Now to find A and B, we're going to take the cubed root of these two here. So we're going to take the cubed root of x to the third and take the cubed root of 125 to get the values of A and B. Now we can't plug the cubed root of x to the third into the calculator because again, both of the calculators that we have don't take the cubed root of a variable, unfortunately. But the cubed root of x to the third we know is x because when the root and the power are the same, they simplify out. So A in our case is going to be x. Now we can take the cubed root of 125 in the calculator and it'll tell us that it is 5. So our B term is 5. Questions on this so far? Now in both cases, with sum and a difference, the first set of parentheses is A and B, just the values themselves. So here the value of A is just x, and the value of B is just 5. Any questions on how we've done this so far? Now for the bigger set of parentheses, we're going to have a squared, a to the first, and then a to the 0. Well, a to the 0 is just 1. We don't include it. Our b terms are going to be b to the 0, b to the first, and then b squared. But we don't include the b to the 0 because they're going in this tier up and down. The first term is squared first, not there. Our second term, we don't include it to the first squared. And for us here, our a term is, again, what? X. So with it, we would have, in parentheses, x squared. The middle, we would have x to the first, and the last one, we would have x to the 0, which is just 1. For our b term, here we would have b to the 0, or 5 to the 0 power, which is 1. In the middle, we would have 5 to the first, and lastly, we would have 5 squared. Any questions on how we factored this here? Because we only have one more step before we're finished. We ready for the next step? Simplify. So in the first set of parentheses, we'll have x minus 5. Now x squared is just, well, x squared plus x times 5 is 5x, and 5 squared is going to be plus 25. So this here factors x minus 5 times x squared plus 5x plus 25. And that's it. That's all we have to do for this here. Any questions on this so far? If we're solving this here, the x squared plus 5x plus 25 has complex solutions every single time. Every single time it will have complex solutions. It does not factor. Are you ready for the next one? So the next one we look at is x to the third minus 64. Well, we can obviously take the cubed root of x to the third, yes? What is the cubed root of 64? What times itself 3 times is 64? So we can do math, cubed root, well, let's get out of that. Math, cubed root 64, enter. It is 4. So that tells us two things. One, that this is the difference of perfect cubes, and 2, that the value of b is 4. Now this here we can set up our parentheses with spaces. The first set of parentheses will have 3, the second will have 5. I call this kind of the tractor trailer, because we have one bigger cab trailer. Now at this point here, we'll do our signs next. And with the sum or difference of perfect cubes, the signs are going to be the same. Opposite always end on a positive note. Well, we start off with subtraction because we're taking the difference. So the first sign will be minus. Our second sign is opposite. So it would be plus and plus. Questions on this so far? So what's the value of a? What's taking a spot? X. So in the first space, we would have x. Then inside the big set of parentheses, we would have x squared, x to the first, and then x to the 0, because that's all the places a shows up. Any questions on this so far? What's the value of b? 4. So in the third spot in the first set of parentheses, we'd have 4. Next to x squared, technically we have 4 to the 0, but that's just 1. In the middle, we would have 4 to the first, and lastly, we have 4 squared. And last but not least, we need to simplify. So we'd have x minus 4. Well, x squared is just x squared plus x times 4 is 4x plus 4 squared is 16. That's it. Questions on this here so far? Any questions over anything we've done so far? All right. Let's look at another one. So this one here, 16s to the 5th plus 54x squared. So again, we need these to be perfect cubes, yes? Can I take the cubed root of 16s to the 5th? Can we take the cubed root of s to the 5th? Well, for us to do that, it either has to be divisible by 3 or it has to be a 3. Well, that's not true. So is there a greatest common factor between these two terms? 2s squared. Because they do have two s's, both of them, so we can pull out an s squared, and we can pull out a 2. And this will help us, because 16 divided by 2 is 8. S to the 5th divided by s squared is s to the 3rd. So some of these, we do have a greatest common factor we have to pull out. Now 54 divided by 2 is 27. And if we factor out the s squared, we're just left with 27. Now the question is can we take the cubed root of 8s cubed and the cubed root of 27? Well, with 8s to the 3rd, we know the cubed root of s cubed is going to be s. If the powers are the same, they cancel each other out. Now we can grab the calculator and take the cubed root of 8, which is 2. We can also take the cubed root of 27, which is 3. So that tells us that the cubed root of 8s cubed is 2s. And the cubed root of 27 is 3. Which means for us, our value of a is 2s, and the value of b is 3. Any questions on any of this so far? Okay. Well, we can go in and plug in our ace, all the values of a. Well, sorry. Let's do the signs first. And what did we start out with? Plus. So the signs are the same. Opposite always end on a positive note. So the same would be plus, minus for opposite, and plus to always end it on a positive note. Same opposite always ended on a positive note. Okay. So our A's are 2s. So in the first one, we would have 2s. Now in the bigger one, we would have 2s squared, 2s to the first, and then 2s to the 0, which we would just leave blank. Any questions on this so far? Now the value of b is 3, so in our first set of parentheses, in the third spot we would have 3. Next to our 2s squared, technically we would have 3 to the 0, which is just 1, so we don't have to include it. Our middle one is going to be 3 to the first, and in the last spot we'll have 3 squared. So when we fully simplify this, we'll have 2s to the third times 2s plus 3. Now 2s squared, we have to multiply 2s by itself. So 2 squared is 4, and then we would have s squared. Minus 2s times 3, 2 times 3 is 6, and we have s plus 3 squared is 9. And that's it. Any questions on any of these here? We'll look at one more of these and then we'll move on to the last part of this lesson. Now when we look at this here, we do notice that both of them are negative, yes? So one of the things we want to factor out is a negative. Now can we take the cubed root of 16? So we can grab this here, say, pull up the cubed root of 16, and we don't get a nice number. But what do we know we can take the cubed root of, and we already have? 8, yes? Is there a greatest common factor of 2 between these two terms? Yeah. So we can factor out the 2. Is there anything else we can factor out? X squared. And we'll need to factor that out because I can't take the cubed root of x to the 5th. So if we factor negative 2x squared out of negative 16x to the 5th, negative 16 divided by negative 2 is going to be a positive 8. X to the 5th divided by x squared is x to the 3rd. Negative 250 divided by negative 2 is going to be plus 125. And the x squared factors out completely. So we have negative 2x squared. Now this will be a sum of perfect cubes. And we can check that by taking the cubed root of 8x to the 3rd and the cubed root of 125. Well, the cubed root of 8x to the 3rd, well, the cubed root of our x to the 3rd would be x. And as we've seen already, the cubed root of 8 is 2. Now, if we take the cubed root of 125, we get 5. our signs are going to be the same. So plus, opposite, always end on a positive note. So plus, minus, plus. Questions on any of this here so far? So A in our case is going to be 2x. So in the first spot we would have 2x. In our second set of parentheses we'll have 2x squared, 2x to the first, and then 2x to the 0. We're just going to leave it without. B in our case is 5. So we would have 5. With the 2x squared, we technically have 5 to the 0, but we don't write that in because it's 1. In the middle spot, we would have 5 to the first, and in the last spot, we have 5 squared. So what that leaves us with is negative 2x squared times 2x plus 5. Now 2x squared, 2 squared, 2 times 2 is 4, and x times x would be x squared, minus 2x times 5, 2 times 5 is 10, and we have x. And lastly, 5 squared, 5 times 5 is 25. Any questions on any of this here? Are you ready for the last bit? So I feel like y'all factoring by grouping. Factoring by grouping is one way we can call these here. I call it greatest common factor twice, or you can say 3 times, but we're pulling something out to see if there's something in common. And you can do factoring by grouping as long as you have an even number of terms. So here we have 4 terms. Now we're not going to look at factoring something out of all 4 terms. We're looking at mainly the first 2. Is there something in common with z to the third and 5z squared? Is there something in common with these 2 here? Yes. Z squared. And I'm going to factor just out of these first 2 here. This seems odd, but it'll make sense in a minute. If I factor z squared out of z to the third, I'm left with z plus. If I factor a z squared out of 5z squared, we're left with 5. Now I'm going to look at these next 2 here. Negative 4z minus 20. Is there something in common with both? Negative 4. Now if I factor a negative 4 out of negative 4z, I'm left with a positive z, yes? Negative factored out of negative 20 is going to make it plus. And if I divide 20 by 4, I'm left with 5. What do we notice about both of these terms here? All right, they have the same z plus 5, yes? So that means I can factor it out. That's why I call this greatest common factor twice, because we found a greatest common factor in the first 2, and it gave us a like term in both of these here. So we can actually factor it out of both. And if I factor z plus 5 out of this first term, what's the only thing that's left? Z squared. And if I do the same thing to the second, I'm left with so when we use grouping, we're really trying to factor something out of the first 2 terms and the second 2 terms. So what we're left with is something that's the same, and then we can factor it out. We can do it again. We're going to do this again. So let's look at this here. So looking at the first 2 terms, is there a greatest common factor between x cubed minus 2x squared? X squared. And we'll factor it out. If I factor an x squared out of x to the third, I'm left with x. If I factor an x squared out of negative 2x squared, I'm left with negative 2. Now what I'm hoping for over here, just kind of like with the last one, is what's inside the parentheses here would be what? X minus 2. Because if that were the case, I do have two, both parentheses would be the same, and we can factor that out. So what do I need to factor out of this here? Because if I factor a negative 9 out of negative 9x, we're left with a positive x. The x's match up. And if we factor a negative 9 out of positive 18, well, the positive is going to turn into negative 2. Now, both of these do have an x minus 2 in common now, so we can factor it out, which leaves us with what? And this is really kind of weird that this works out this way, but it is kind of nice that it does. Any questions on any of this here? We'll look at one more of these here and then we'll be done with this part of the section. Do we want to look at 6 or 7? 7. So we can pick these first two terms, 3y cubed plus y squared. What's the greatest common factor between these two here? Well, there's not a number, is there? But we do have a y squared. So if I factor a y squared out of 3y squared, we're left with 3y plus. What happens when I factor y squared out of y squared? We get whenever something factors out completely, we have 1. Plus, what is our greatest common factor between 9y and 3? 3. So if I divide 9 by 3, we get 3y plus 1. Now what's in common with both of these here? 3y plus 1. And it's being multiplied by y squared plus 3. And that's it. Any questions on any of this here? And that is it. That is all we are doing for today. So 5, 7, and 11 are our factoring greatest common factor and then kind of using the properties we already have. 15 through 18 is our sum and difference of perfect cubes. 24 through 26 is our factoring by grouping.